Okay. Hi everyone. Today we will discuss about the review some basic statistical concept. This is actually the topic that we need to cover in Learning Unit 2. For your information, things that we are going to discuss in this chapter is just to recall back to what you have learned uh, uh, when you were taking statistic course. Okay, and then we just straightforward to discuss about the key point, the key point and the tools, and also the test that you need to know before we proceed to apply it in while we are trying to uh, apply the economic theory and then try to figure out the statistical evidence and the mathematical evidence whether the theory is significant in the real life or not. Okay, then we need to recall back to some basic technique in statistics that we are going to use. First of all, we need to know about the observation. Okay, so if you recall back to what you have learned in statistics, there is a word to call as an observation, especially when we want to do a regression estimation. So the observation here derived from either the populations or sample. Okay, you need to aware about to have a good knowledge about what is the difference between population and the sample. It is depends on the study that you want to do, what you want to explore. If let's say it is possible for you to involve all population become your observation, then it is fine. But if let's say the population is too big, then uh, it is not really practical for us to collect the data or the informations uh, to the information for all population. We just can we just can use sample to represent the population. So now I will give you the example. If let's say a case example like a case that you can collect a population observation example that you want to make a study about the consumption behavior in your class. So it is possible for us to collect information for all students in our class. But if let's say if you want to study about the expenditure behavior uh, in Sarawak, example, even though in Malaysia, then it involves a million, a multi-million of population that we need to cater. So in this situation, we can use sample. Okay, sample. So if let's say, regardless we use, if let's say whether we want to use population or a sample become our observation, we need to choose the what do we call it? We need to choose the correct tool for statistical inference. This is what it means. So that is what I mean just now. We need to understand what is the difference between population and the sample, especially the sample, because the sample here is just a small portion of population to represent the sample, the population. So, meaning to say that we need to have a good quality of sample that can represent the population. Okay. And then we are also talking about the statistical inference later, but then for this introduction part, I just highlight you the difference between the population and the sample. Okay, there are a lot of technique for us to form a sample. Okay, You will learn in detail in research methodology course with Dr. Liu. Okay, and then there is a technique for us to form a sample, and then just for your information, these are some of that which you can do: random sampling, discrete random variable, continuous random variable. Okay, I will leave it to your coordinator for the subject of research methodology to explain in detail about how to form a sample. Okay. Then another thing that you need uh, to understand, there is a data that we cannot transform directly into the numbers. Okay, one of the information is we call as a dummy. Okay, a dummy is just involve two types of value, whether it is 0 or 1. Okay, normally for dummy variable we normally use for gender like female and male. Example here, female and male. Female equal to 0. Male equal to 0. Female equal to 1. So in this case, actually, male also can be 1. Female also can be 0. Okay, it does not matter. Meaning to say that here 0 or 1, it has nothing. There is no meaning. It is not an information to say that 0 is greater than 1, 0 is smaller than 1, okay, or 1 greater than 0. Okay, it does not reflect to any monetary value here. It is just the dummy variable. The purpose for us to have a dummy variable is to split the sample or the observation that we have, to split in terms of the gender, okay, to split based on race, to split based on the citizen, or to split based on the income classification. But I want to highlight you about the income classification here. It is not just not it is just not mean it does not mean we just have poor or rich. We can rank it 1, 2, 3, 4, 5. So in this case, actually, income. If let's say you want to have two options, poor or rich, then you can use dummy variable. If let's say you want to rank it based on income, then dummy variable is not suitable. As I told you just now, dummy variable is to approximate something that not related to monetary value like this. Okay, and then other than that, in economic we use dummy variable to split the period. So you will learn in details in the next chapter, but I will try to cover this chapter when we are discussing about the time series, the introduction of time series analysis. Okay, so then we go to the tools. Okay, the basic tools in statistics that normally we going to use to explain about the data, to explain about the variable in general. The first one is mean. Okay, mean is actually referring to the average value of uh, our sample or observation. Example, okay, you have a data set about the expenditure of a population. So in order for us to know the average level of income in that particular population, then we just can come up with the average. Okay, average. Then it refers to mean. Maybe in your mind, will think that this mean information translate an informative or accurate information. That one another question. The one of the advantages, if let's say we want to use mean, then it is easier for us to explain about the level of income in that particular area, in that particular population area. But then it becomes misleading if, let's say, example, that population is not integrated, or there is not much activity of what do we call as people to people connectivity. Meaning to say that if we recall back to the theory of circular flow activity, right? So if they say there is quite how can I say, less people to people connectivity, then the money volatility in that area is quite low. So in this case, actually, we can say that it is quite difficult, or it is quite mm, it is not that meaningful for us to use mean to give a picture about the information related to the level of income of that population. Another example, you want to come up with average of income population in one area, let's say area A, and then you also want to collect, you also have the information about the income of population in area B. Then you want to compare the level of income in area A and in area B. Then you use mean. So the mean value here is easier for us to compare because it involves with one single number. But whether it represent or give a clear picture about the exact information or level of income to represent that population, that one is another question. This is the disadvantage when we use mean. Okay, like let's say we try to use another example. In that population, we have A, B, C, D example. I mean, if it's referring to the individual. Individual A, a rich group, okay, super duper rich. Individual B, C, D is not that rich, just a moderate. But then when we use mean, if we use mean value, it means that the monetary value for person A can be easily transfer to person B, C, D. So if we apply it in the real world, then it is impossible. It can be done, but we need to have threat activity. That's why I said, if let's say that area or the population in that area is not really active in terms of people to people connectivity, the mean value here seems like not that accurate. This is what it mean by mean. Okay, there are other tools than mean that we can use. Another example like median and also mode. Okay, it depends on the data that we have on it, or it depends on the subject that we want to discover. So from that, we will know whether mean or median or mode is most suitable. We will look further on this when we are doing some practical activity. Okay. Second one is the variance. Okay. Variance and or standard deviation is almost the same. They want to variance and standard deviation tries to deliver the same information. Okay. If in this slide, let's say we use variant as the term here, regardless the term of variant or standard deviation is it actually deliver the same information. So let's say now we are focusing about variant. Variant is all about to give us further information about the mean. Okay. The variance here is a value to say how much different of one individual or one observation with the value of mean. Example, the income just now. If let's say the mean value is let's say 50, let's say 50 ringgit, but one individual have 1,000 in 1,000 ringgit in their pocket. So the difference between 1,000 and 50, that is the variance. Okay, that is what it means by the variance. How far one individual in that observation from the mean. Okay, if let's say we have a wide difference between the actual value and the mean itself, meaning to say that our data is not to say not accurate, but something that we need to look further. Example, if let's say too much observation is very far away from mean value, meaning to say that it is not really represent the the behavior of that population. This is what it means. Okay, so maybe now you are not very clear or not that clear about variance and how to apply it when we have the information. We will discuss further when we do some application to use the real data. Okay, another one is the covariance, and covariance and correlation also delivering the same information. Okay, the covariance here is talking about the relationship among two factors. Example, okay, just now we have collected the data for expenditure. Okay, on the other hand, you are also collected the data in the data of the income. So theoretically, we believe that if let's say we have high income, then we will spend more. Okay, that is the theory, meaning to say that it should be have a positive relationship, theoretically. But we want to come up with the evidence to support that theory, to support that assumption. We can use covariance to confirm it. So, meaning to say that the covariance will provide you an evidence in terms of the mathematical terms. So let's say here, if let's say uh, the covariance value between expenditure and income should be positive. So definitely the covariance value is positive. Then because the positive value for covariance means that these two variables move in the same direction. So if let's say it's zero, there is no relationship. Okay, if let's say negative, there is a different direction. Okay, we will do an exercise to have further understanding about the covariance, how we can apply it in informing or to transform the raw material or the raw information become some meaningful information. Okay, we can illustrate in terms of the graph too. Okay, let's say the covariance is if let's say the covariance is positive or negative or no if or zero. Okay, correlation also talking about the same thing. But then the correlation here, if let's covariance, you can report the analysis based on the graph, but the correlation you can represent, uh, you can explain or elaborate the finding from the correlation based on the figure. How many percent it influence the other variable. Example, how many percent, the strength, how many percent of income to influence the behavior of expenditure. Okay, as I told you, it should be like this. Same thing with the covariance, and then the correlation also. But then the correlation we can use the numbers to explain the magnitude. Okay. So so it is the numbers is actually uh, should be from 0 to 1. As I told you just now, if you're referring to the previous slide, okay, the covariance, one of the weaknesses, if let's say you want to use the covariance here, you are unable to know the magnitude. I mean the strength about these two couples of variable or factor. Okay, and then the correlation here, for example, here that's why the correlation have a rank. Okay, have a rank. The correlation value here is not going to have beyond than 1. So it is as range as 0 to 1. Example, if let's say you you figure out or you find out that your correlation value is 0.5. So it indicates that the relationship, the strength of the relationship among this variable is somewhere around 50%. So this is what it means. Okay. So if let's say the value is 1, meaning to say that the correlation value is equal to 100%. So if let's say 0, no correlation or no relationship. But if let's say uh, the sometimes uh, it can be negative, but then it represents as the relationship. Okay. Okay. So so other than that, other than that, we also have a tool to know whether our assumption is mathematically correct or not. Okay, for example, like we can use t value. Okay, the t value here, if let's you need to take note here. If let's say your observation is a population, then the calculation for t value should be different. So if let's say you are using a sample, the population, then your observation is a sample. So the calculation for you to come up with the t calculation, t test is also different. So another thing that you need to aware is that the t distribution can be two tails or one tail. So in this slide, example of two tails. Okay, and then one tails. When we need to apply one test or two tests is subject to the study that we want to explore. Example, about you want to study about male behavior. Example, okay, then it is very specific to male behavior, meaning the behavior of one particular gentleman, okay, one particular gentleman, and the ladies have no behavior as a gentleman. So we have a narrative about that in one study, then we can use one tell. So if let's say in our study we have the what do we call that? Uh, we have the very general or what do we call as a very general or very universal information, then we use two tell. Okay. Another one you can use chi-square. Okay, the chi-square also we try uh, to know example. Okay, we want to know whether the samples can represent the population or not. So we have two types of samples. Example that you are collected. Example, you are collected the expenditure behavior in area A, the expenditure the expenditure behavior of a population in area B, then you want to know whether they are sharing the same behavior or not. So we use chi-square. This is what it means. Okay, and another thing that you need to know here, if you are using the chi-square, be careful with the degree of freedom. Okay, the degree of freedom, the way you make a decision about the degree of freedom, about the whether it is significant or not, then we need to refer the degree of freedom. Okay, we will discuss further. So another type of test to ensure our estimation or our assumption or our prediction is correct or not, we need to do some tests. Okay, like normality test, autocorrelation test, heterogeneity test. So this one we will discuss further in the next chapter. Okay, these are the summary of hypotheses. The t-value that I mentioned to you, if let's say your t-value, if you want to calculate your t-test from sample, should be have it for sample, and same goes to the population. Okay. So again, if you look at this graph, okay, the K here is representing the degree of freedom. Okay. When we are doing a statistical division, t-value plays, no, the degree of freedom plays a very significant, factors or things that you need to concern. Okay, we will discuss further when we do some exercise on regression. Then I believe that it is clear for you to understand why we need to concern very much about the degree of freedom. Okay, and then for this one, for conjugation test, the significant test, stationary test, we will discuss when we will discuss further in time series analysis chapter. Okay, right. This is the t test with two tells, okay, one tells, and I already explained you in what situation we can use one tells and in what situation we can use two tells. Okay. F test, another one, another tools that you need to understand, and I believe you have learned in statistics. So F test is all about a joint of factors to cost dependent. Example, okay. So we have the data of income, and we also have the data for expenditure. Then we add on another factor, another independent variable. Okay, the independent variable here, example, we want to collect, we are collecting the data related to education, example. So how about if let's say we combine the factor of education and income? Okay, if we combine the education and income, how it influence a change in expenditure behavior. So in this case, we want to know a joint of income and education and it how they play their role to influence the expenditure. Okay, same thing. F division or F test also uh, have have its own normal distribution. Okay, so we also learn in details about Ramsey test when we are discussing about the multi-collinearity learning unit. Okay, theoretically, we stop here for a while, and then we will continue our lecture with some application. Okay, I will share you the data, and then you need to install the eViews, and then you need to do an exercise and do together with me a hands-on activity about the how are we going to apply the knowledge of mean, median, mode, and just now we also discussed theoretically about covariance and then correlation and also some t-test, f-test, and chi-square letter. Okay, so I think it is quite difficult for you to understand without any practical activity. Let us have a break.